In sections 2.1 and 2.2, we will be introduced to the rectangular coordinate system, also known as a coordinate plane, and we will start talking about lines. So the coordinate plane has an x-axis, which is the horizontal axis, the y-axis, which is the vertical axis, and the origin is right in the center. The coordinate plane is also divided into 4 quadrants, quadrant 1, 2, 3, 4, which are labeled going counterclockwise, and any point P can be represented as an ordered pair, x comma y. X is the horizontal coordinate and y is the vertical coordinate. Let's plot each of these points and identify which quadrant the point lies in. So let's take the point -4, 3. So the x value is -4 and the y value is +3, which means from the origin, we're going to go 4 units to the left and we're going to go 3 units up. So this point has an x coordinate of -4 and a y coordinate of +3. The next one is 2, -4. So we have an x coordinate of 2 and a y coordinate of -4. Next, we have -2, -5. We have an x coordinate of -2 and a y coordinate of -5. So the first value tells you how much to go left or right. Second value tells you how much to go up or down. 3, 2, the x coordinate is 3 and the y coordinate is 2. So we're going to go right 3 and we're going to go up 2. 0, 5. So for 0, 5, the x coordinate is 0, which means we don't go left or right. We stay in the middle. And the y coordinate is 5, so we're going to go up 5. And then lastly, we have -3, 0. So -3, 0, it means the x coordinate is -3, so we go 3 units to the left, and 0 means we stay in the middle. Now we're going to start talking about different ways of graphing linear equations. So first off, a linear equation is any equation that has a y and x in the first degree. So in a linear equation, it can take on a couple of different forms. It can take on the form of ax plus by equals to c, where x and y both have an exponent of 1. You can also take on y equals to mx plus b, where once again, the x and y have an exponent of 1. So anytime you see an equation in this format, we know it is going to be a linear equation. Now, the x-intercept is a point at which the graph touches or crosses the x-axis. So the x-axis is the horizontal axis. Now, if we follow this line, we're going to follow it, follow it, follow it, follow it, follow it. It's going to cross the x-axis right here. And this point is 4, 0. Let's take a look at the next one. If I follow this line, remember, I'm looking at to see where does it touch or cross the x-axis. It's going to cross the x-axis right there. So that point is 2, 0. And in this case, if I follow my line, this is the x-axis. They cross at the point -5, 0. So I'm going to list these x-intercepts. For the first one, it was 4, 0. For the second one, it was 2, 0. For the third one, it was -5, 0. Now notice what they all have in common. For any x-intercept, all the y values are equal to 0. And that's not a coincidence. The reason that the y value is 0 is because let's say the y was equal to 1. So these are all the y values. If the y was equal to 1, then we would end up here. If the y was equal to 2, we would end up over there. To end up on the x-axis, the y value always has to be 0. That's the only way you can end up on the x-axis. So for any x-intercept, the y value always has to be 0. Now let's look at the y-intercept. The y-intercept, by definition, is a point at which the graph crosses or touches the y-axis. So this is the y-axis here. Okay, I'm going to follow my line, and it's going to hit the y-axis right there. The x is 0, and the y is 2. Here, if I follow my line, it's going to cross the y-axis right there, and that point is going to be 0, -6. Over here, my line is going to cross the y-axis right there, and that point is 0, -5. So if I list my y-intercepts, I have 0, 2, I have 0, -6, I have 0, -5. So notice that for all of these, the x value is equal to 0. So we're going to use this to find x and y intercepts. To find the x-intercept, we always have to set the y value equal to 0 and solve for x. Because when you set the y value equal to 0, this is like y equals 2, y equals 1, you automatically end up on the x-axis. To solve for the y-intercept, we are going to set the x value equal to 0 and solve for y. So here is an example. We want to graph the equation 3x minus 2y equals to negative 6 by finding its intercept. So we need to find the x-intercept and the y-intercept. Now, in the previous slide, and also over here, we're told that to find the x-intercept, we have to let the y value equal to 0. And to find the y-intercept, we have to let the x value equal to 0. And then solve for x or solve for y. So I have my equation 3x minus 2y equals to negative 6. And let's say that I'm looking for the x-intercept. To find the x-intercept, I have to set the y value equal to 0. So instead of 2 times y, I'm going to replace the y value with a 0. So this is going to be 3x. 2 times 0 is 0. That equals to negative 6. And then we divide both sides by 3 because the opposite of multiplying is dividing, and x will equal to negative 2. Now we have to be careful because any point has to be written as an ordered pair. So the x value is negative 2, but remember we set the y value equal to 0. So my x-intercept is going to be the point negative 2 comma 0. Now let's look at the y-intercept. To find the y-intercept, we need to set the x value equal to 0 and then solve for y. So in my equation, 3x minus 2y equal to negative 6, instead of an x value, I'm going to replace that x value with a 0. That's how you find the y-intercept. So this is going to be 0. We get negative 2y equal to negative 6. The y is being multiplied by negative 2, so we divide by negative 2, and we get y equal to 3. But we can't stop there. We have to write any point as an ordered pair, which means an x and a y coordinate. So for the y-intercept, we set the x value equal to 0, the y value is 3, and this will be the y-intercept. Okay, so if I graph this, this is my x-intercept negative 2, 0. This is my y-intercept 0, comma 3, and I'm going to have a line through these 2 points. Okay, the next example, let's do this one in class. Here's another example. We want to find the x and y intercepts of the equation y equals to negative 3x plus 18. So let's first find the x-intercept. And remember, to find the x-intercept, we are going to set the y value equal to 0. So if I replace the y with a 0, I'm going to get 0 equals to negative 3x plus 18. Okay, so I take this y value, replace it with a 0, and solve for x. This is an equation. For any equation, we have to get the variables on one side and the numbers on the other side. So I can either add 3x or I can subtract 18. It doesn't matter. I'm going to add 3x. So what that does is on the left side, I get 0 plus 3x, which is 3x. On the right side, I get 18. And since the x is being multiplied by 3, I divide by 3, and I get x equal to 6. But remember that any point has to be written as an ordered pair. So my ordered pair is going to be the point 6, comma 0 as my x-intercept. So for x-intercepts, and I know I'm repeating myself, but the more I say it, the more you might remember it. So for the x-intercept, the y value always has to be 0. Okay, now for the y-intercept, we're going to do the opposite, and we are going to set the x value equal to 0 and solve for y. So in my equation, y equals to negative 3x plus 18, the x value is going to get replaced with a 0 because this is how we find the y-intercept, by setting the x equal to 0. So anything times 0 is 0, so we get 0 plus 18, which is going to be 18. So my y-intercept is going to be the point 0, comma 18. Another cool thing is anytime you have an equation in the form of y equals to mx plus b, and you want to find the y-intercept, if you replace the x with a 0, this whole thing just goes away. So whatever the b is, that is always going to be your y-intercept. It's kind of a little shortcut. So this next one, let's do in class. And let's take a look at our last example. Suppose you were given $900 from your uncle. You deposited that money in a bank and added $65 per month. Write an equation to model how much money you have deposited after m months. Let S be the amount you have deposited. So let S equal to the amount of money in your account, and we're going to let M equal to the number of months. So I'm going to say S, which is the amount of savings I have. So remember, I start with $900, and every month I deposit $65. So because it's $65 per month, it'll be plus 65M. The 900 doesn't have a variable, it's a fixed amount. Your uncle gave it to you one time. Your uncle's not giving it to you every single month. But every month you are getting $65, so it's going to be 65M. Okay, part B says, how many months would it take for you to save $10,000? So first question is, what are we looking for? We're looking for the number of months. What are we given? We're given that we want to save 10,000. So in my equation, I'm going to replace the S, which is my savings amount, with 10,000. So I'm going to get 10,000, which is my savings, equals to 900 plus 65M. Okay, now I'm looking for M because I'm looking for the number of months. So the first thing we have to do is we have to get the 65M by itself. This is just like solving an equation, so we are going to subtract 900 from each side. So if I take 10,000 and I subtract 900, this gives me 9,100 equals to 65M. Now the M is being multiplied by 65, so I divide by 65. And this gives me 140 months. All right, think of any questions you guys have, and I'd be happy to go over those in class with you.